I'm Anil Kumar. Welcome to my series on discussing some challenging questions. Here we'll discuss trapezoid. Always in a test paper, the question based on trapezoid is kind of tricky. The question here is, consider an isosceles trapezoid ABCD shown in the figure. BC is parallel to EF is parallel to AD. So these sides are all parallel, horizontal. Measurement of angle EBC is 120 degrees. So this is 120 given to us, right? And measurement of angle GBC, this angle is 30 degrees. Okay. So we are given this angle as 30 degrees. Total is 120, and therefore this angle here will be 90 degrees, correct? So basically we do have a right angle here, correct? Okay. Now we are also given here 60 centimeters is BC. So BC is 60 centimeters. Now the question is to find ratio of EF to AD, right? Ratio of these two sides we need to figure out. Okay. So let's try to understand. So what we have here is isosceles triangle, right? So the angles at the base are same. So this is 30 degrees. That means this is also 30 degrees. So we have an isosceles triangle. Now let's drop a perpendicular from G to BC. So if I drop a perpendicular from here to BC, in that case, these sides will be half of 60, so we'll get 30, 30 each, correct? So that is the perpendicular which we have just sketched from G to BC. Now what you get here is a 30, 60, 90 triangle, correct? So we can find all of the dimensions using this 30, 60, 90 triangle. So in a 30, 60, 90 triangle, the ratios are 1:2 square root 3, correct? Where this angle is 60 degrees, the other is 30 degrees. Right. So here is our 30, 60, 90 triangles. So from the ratio of the sides, we can actually find all the sides, correct? Now since the side adjacent to 30 degrees is 30 centimeters, the side on the other side will be 30 divided by square root 3. So that is divided by 3 times square root 3. So this side here will be 10 square root 3, right? So this will be 10 square root 3. So let's call this point as a P point. So we have G to P will be equal to 30 times square root 3 over 3. So that gives us 10 square root 3. Now, if you look into the triangle, which is on the right side now, this is also a 30-60 triangle, correct? So in the triangle GPC, we know now this side is 10 square root 3, the other one is 30. The hypotenuse will be twice this side, correct, which is adjacent to 60. So here G to C will be equal to 20 square root 3, right? So that becomes 20 square root 3. Now this side, this is 90 degrees, so that is again 30 degrees. So we again have a 30, 60, 90 triangle. This side here is 90 degrees, correct? Isosceles triangle. Okay, now that is 90 degrees. This is 30. Again, we have 30, 60, 90 position. So working again on this, now this time our hypotenuse is 20 square root 3. So the side here will be the hypotenuse we need to figure out, but the side here will be divided by square root 3, right, which will be 20 for us. And this is the hypotenuse, which is going to be twice 20, right, 1:2 ratio. So that becomes 40. So we can now work out all the sides. So here in this triangle, we have GC is 20 square root 3 and C to F will be 20 and G to F will be 40, all are in centimeters, correct? So using 30, 60, 90 triangle, first step is to work out all the sides. You can use tan ratios and sine and cosine ratios for 30, 60 triangles to find the side lengths also. Okay, now we are given that these lines are parallel. So let's consider the triangle ACD and the triangle GCF. Now these two triangles are similar since we have these two bases parallel, correct? So when the sides are parallel, this angle is 30, that is also going to be 30, and we have a common angle there, right? So from angle property. So these two triangles which are diagonally, we are working on this now. So this big triangle and the small triangle, they are similar triangles. Now once we show that they are similar triangles, we can find the ratio of sides, correct? Now you can also see that in this particular case, since we have one side as 40, if you look into it, the angle here is 60 degrees, and therefore this angle is 30 degrees, correct? So this is also an isosceles triangle, that is also 30 degrees. So that means these two sides should be equal. So if this is 40, that should be equal to 40, correct? So we can find that D to F is also equal to 40, right? Since we have the triangle which is an isosceles triangle, correct? So okay, so we get one full ratio here. That should help us to get the ratio of GF to AD, correct? So from similar triangles, we get the ratio of GF to AD as equal to CF to CD. Now C to F was 20 as we calculated, and C to D is 20 plus 40, right? 20 plus 40, which is 60, correct? So that gives you 20 over 60, or 1:3. So the ratio of GF to AD is 1:3. We need to find the ratio of EF, right? So if you just multiply this by 2, so GF over AD is 1/3. But EF is twice GF, right? So we want to find what is EF to AD, right? Now EF is twice GF, since this side will be also equal to that side, right? That's the midpoint, over AD. So that should be twice 1/3 or 2/3. Correct? So our answer is that this ratio is 2/3. Now this is a very important exercise, and that helps you to clearly work through these sides as we have done systematically. And if the case is 30, 60, 90, you can use this triangle to figure out all the dimensions. Once you have those dimensions, then use similar triangles. These two are parallel sides, right? So the triangles are similar, and get the result. So I hope the steps are absolutely clear. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.